Hello, everyone. My name is Jonathan Ling. I'm the head of product at a company called TrackVision AI. We're a traceability software company, just like Kessler, and we help businesses leverage the latest GS1 standards that we're talking about today to cost-effectively meet traceability, quality, and sustainability goals. So the objectives of today's talk, we wanted to help you understand the GS1 digital link and EPCIS standards in a little bit more detail, real practical examples. And we'll see how these standards are being applied in a fresh produce case study. We'll see business objectives, we'll see how GS1 standards are being applied, and we'll see the technical components used in the implementation. We're going to go step by step and look at all the logical parts of the puzzle that are brought together to implement the business outcome. So let's first of all start with what is GS1 digital link. GS1 digital link is easiest understood as the barcode of the future. So why not start with the humble 1D barcode from retail? So we all know that inside that 1D barcode is a global trade item number, which represents a type or class of product. What if we took this global trade item number and we placed it in a structured position in a web address? So here we've placed our GTIN at the back of our web address, and before that we've prefixed it with a little code, and that code is none other than the GS1 application identifier that says the next piece of data in this sequence is the GTIN. We make sure this is a valid web address, and then we can take this whole web address and we can put it inside a QR code, and we can use that as the data carrier that can be placed onto a product or package. And now we can use that instead of the traditional 1D barcode, and we'll see the advantages in a second. The nice thing about digital link is it can model more than just a type of product. So for example, if you have a batch or a lot, in today's world, you'll see a GTIN on the back, and then you'll also see like a lot number printed in human readable form and an expiry date somewhere in there. What we can do is we can take these attributes, and again, we can lay it into our URL, into our web address, in structured positions, prefixed with the GS1 application identifier that describes the piece of data afterwards. So here I've got my GTIN and I've got my batch. Now this web address represents just that batch of products, separate from all other batches of products. I can do it as well at an item level. If I have an item GTIN and I have a serial number that uniquely identifies that individual instance, again, I can take these two elements, I can place it into a web address, and I can make a GS1 digital link that's globally unique, put it in a QR code, and put it on my package. And we can also apply GS1 digital link for logistics units. So again, here we can see a 1D barcode that places an SSCC after the SSCC application identifier. Do the same thing. Let's make a web address and place it into the web address. Now we've got a much more powerful barcode for the future. We can also do it for global location numbers, for example, factories and production lines and other things like that. Again, just placing the GLN in there, prefix with the application identifier that represents GLNs. So what are the big advantages of digital link? There's three of them. One is it allows data capture and identification without an internet connection. So classic example, a point of sale system, usually scanning 1D barcodes. Now it could scan a 2D barcode like a QR code or a data matrix, and just strip that GTIN out and look it up in its local database and print out receipts and show prices and so on, right? Secondly, it's obviously a web address. So that means I could scan that QR code and my browser could load that web address, and then it could go to some digital content that the brand has prepared for me. Very, very useful. There's actually a third kind of secret advantage as well. It can actually act as an API. So you can write a program or write an application that can get that web address, affix a parameter to it, and ask for specific information. So in this example, we've got a startup that's creating an allergen app, and it could interrogate the digital link and say, hey, give me allergen information specifically. And a manufacturer could set up a system that returns just that information. It could be human readable web pages, but it could also be machine readable information like EPCIS or GS1 web vocabulary, so that the program knows how to work with structured data and display it on the screen. Let's talk about what EPCIS is. So EPCIS, as we've heard today, is a data model, first of all, to record any supply chain process as a series of discrete events. And each of those events has attributes like what, when, where, why, and how. So let's go through an example. What if I'm making iced coffee? What if I'm making a production run, which is a specific batch of iced coffee? I'm making little bottles of that. Well, there's going to be inputs into my production run. There's going to be a batch of sugar. There's going to be a batch of coffee beans, and so on. So what we can do is we can actually create an EPCIS event that models that specific business operation. The where dimension is quite simple. It's a reference to the global location number of my factory, which is great. The when dimension is exactly when the production run finished. The what dimension consists of a few parts. First of all, there's an output, which is my batch of coffee with a quantity. And there's some inputs, which is, a specific amount of sugar and a specific amount of coffee beans from specific batches with specific GTINs, right? And then there's a Y dimension saying what was going on in the business when this event occurred. Well, it was a transformation event as part of commissioning this output production run. So we can keep using EPCIS to capture the rest of the supply chain. So for example, if I take individual bottles, pack them into a pallet, I can create a EPCIS event that says, hey, at the factory at a specific time, I'm packing into a parent SSCC 400 bottles from a specific batch. And we heard that with Tesla as well, that packing individual quantities of batches into reusable asset containers. So we're doing the same thing here. The why is, well, I'm packing using a consistent vocabulary that everyone in the supply chain understands. Next thing I'm going to do is I'm going to grab that pallet. I'm going to ship it out of my factory. Again, we can have a shipping event that says, hey, from the factory at this point in time, this SSDC left the building. The reason was I'm shipping it out. And then at the retailer side, they could capture an EPCIS event saying, hey, I'm receiving this pallet. And it happened at this specific time at my global location number for my retail store. And one thing we haven't talked about is the how dimension. That's new in version 2 of EPCIS. It can record things like sensor data. So if my truck was equipped with a cold chain monitoring solution, we could actually say that during that journey, the minimum temperature was 3 degrees, maximum was 4 degrees. So that retailer could say, could start monitoring that the cold chain integrity stayed true. The second thing EPCIS does is it defines a set of standard APIs to allow businesses and systems to exchange these events. The first and most important one is what's known as a capture API. It allows me to push data into an EPCIS repository. Classic example, a manufacturer shipping a pallet of goods to a retailer. I want to know, the retailer wants to know, well, what's inside that pallet? And for each object inside that pallet, maybe where did it come from? What were the provenance of it? Or maybe even the components of those items. We can model all of that as EPCIS events and push that proactively to our customer. And they're happy now because they've got that transparency and traceability that they require for their business. The second thing that we can do is we can query a repository to get data back out. So maybe I'm interested in checking, hey, did you receive a pallet that I sent you? Well, I could do a query and ask my retailer's EPCIS system, yeah, did you get that pallet? And they can say, yes, I did. I received it at this moment, and that's fantastic. The third thing we could do is we could set up a proactive subscription. I want to be sent data proactively that matches a specific criteria. So it's boring to always do queries. So why don't I just tell that retailer, hey, anytime you see any receiving events with my company prefix in the SSCC structure, can you just send them all to me just proactively? I don't want to have to check with you all the time. So you can set up a subscription and get sent events that match that criteria. This all matters because we're trying to reduce data exchange cost to zero. The more adoption of EPCIS, the more systems that support EPCIS, the cheaper all of this data exchange will happen. And that's a good thing when it comes to complying with things like regulation that we can't get out of. So today we're going to explore a traceability implementation in the Australian table grapes industry. The Australian Table Grapes Association, which is an industry body, backed by the Australian government and GS1 Australia, is bringing traceability and product digitization capabilities to its 900 grower members. The project was launched in 2022 with a major grower and is now expanding with new extensions and integrations to support adoptions by growers of every size, small, medium, and large. And they all have different requirements, and we're trying to find ways of supporting them all. So as a company, TrackVision, we're proud to deliver our GS1 compliant technology, which I'll show you at the end, in collaboration with other solution partners in the program. So the solution in a nutshell. First of all, the first thing we want to be able to do is we want to uniquely identify individual items and cases with GS1 digital link. And we're actually going to use serialized digital links in this scenario. You don't have to, you can do batch level digital links as well. But here we're going to do serialized for a few reasons. The next capability we're going to be able to do is trace the input produce that went into those packaging back to source. So what farm, what patch, what variety, and all sorts of stuff. We're even going to be able to share credentials and certifications that those farms hold if they want to share that. As we move downstream, we'll track the packing hierarchies. Cases go into pallets, and pallets move through the supply chain, through exporters and onto retailer customers. And we'll be able to use EPCIS to also collate cold chain data. So relate the cold chain sensor data to the supply chain and all of the nice related data within. And finally, we can have QR codes on these products and cases to let consumers and wholesalers interact with the products via GS1 digital link and scanning those web addresses in QR codes. And it's actually a two-way street, which is really, really cool, actually. So they could put a complaint in, or they could give feedback saying this was excellent produce. And we can grab all that data and we can start to reveal trends, and it's so much more actionable because it can be connected to how the product was actually distributed or what the exact farm material that went into it actually was. The business benefits for this project, it's all about maintaining a premium position in the export market for Australian grapes. So we're going to do that by assuring customers that they're getting a genuine product. We're doing that with serialization and an authentication flow with QR code scanning. We can engage the customers and wholesalers by differentiating our brand and being really transparent with provenance and translating information into a local Asian language, for example. We can enable ongoing business improvements, as I said before, by getting that any complaints or feedback back from the customer base. We can combine it with supply chain data to actually improve our business operations. We can enable rapid quality incident investigations, classic trace back, trace forward, and reviews of cold chain in context, which is really great. If a recall did happen, we can protect consumers by allowing them to simply scan a QR code and check, am I affected by that recall or not? Instantly check. If they are, give them some remediation actions that they can take. And finally, we want to maintain our supplier relationships by detecting unauthorized product diversion. So each supplier has a territory they're supposed to service. When they divert product that then into other countries, that's not good for other suppliers from a commercial perspective, safety perspective, labeling perspective. There's a whole bunch of reasons why that shouldn't be done. So using this framework, we can start to detect that movement when people interact with QR codes and say, that's not a good thing. Let's try and address it. So how are we using EPCIS to record our processes? Well, it all starts on the farm from a specific patch where there's grapevines that we're going to harvest fruit from. So the first thing we're going to do is we're going to define a lot number for that action of harvesting fruit from that patch. There'll be a quantity of fruit, so we can, in a high volume situation, we can count by using totes and weighing, but in a smaller situation, we might also be able to count the amount. The location will be a global location number with a GLN extension that talks about which patch within the business address of the farm. And the reason was, well, we're commissioning a new batch of produce out of the ground. The next thing that happens is we bring the produce back to the shed, and we're going to put them into cases of fruit. We're going to pack them into cases of fruit. So we're going to make a production run of cases. And we're going to, again, assign a lot number to that production run, and it's going to have a product and a GTIN. And we're going to say, hey, this quantity of raw produce from this patch and this patch went into this production run of 900 cases that was produced at a specific time at a specific packing shed, which is also identified by a GS1 global location number. And the reason here is, again, commissioning an output batch, it's a transformation event. One thing we're doing special on this project, so far we're talking about lot level traceability. We're actually going to move to a serialized model. So what we do is we have dynamic printing going down on the production line, printing out a label with a serialized GS1 digital link. And we're doing that in context of a production batch. So again, we can record an event that records the birth of that serialized identity into the world. It'll have the serialized GTIN as the primary what identifier. It'll have a reference to the lot number that it was produced in context of, and it'll again have the location where it was produced, the time when it was labeled, and the reason is we're commissioning that serialized identifier. The next thing that happens is packing those cases into a pallet. We're going to use a GS1 EPCIS aggregation event. The reason is we're packing, and the location is wherever I'm packing, and the parent is the SSCC. The children are the serialized identities that we're actually packing inside. The next thing that happens is we ship those pallets out to exporters. So we're going to scan those SSCCs, put them on the truck, and we're going to record a shipping event that says we're outbound from a specific location, and the target is another location. That exporter is going to record a receiving event. Again, the reason is, well, I'm receiving something. The what dimension is an SSCC. The time is whenever they received, and so on. And the final step where we're going to record is shipping to an end retailer. Again, you've got an SSCC that starts at a location and shipped to a destination at a specific time, and the reason is shipping. One thing that's not on my slide here is the cold chain stuff. So we'll have an association event that associates a device to a SSCC, for example, and then we'll be getting information back from that device, and we'll be able to cross-reference that to the SSCC and the other objects in that shipment. So the final thing I wanted to do really quickly is walk you through step by step what technical components would you need to create a solution like this. So let's start from the consumer's point of view when they're scanning the QR code. So the first thing that happens is the QR code is loaded by my mobile phone into the mobile phone's browser. And the browser will do a web request saying, hey, can I have a web page for this digital link? And the piece of infrastructure that will handle that is called the GS1 Digital Link Resolver. So that's actually hosting the digital links, and it has some logic in it that says, when someone in this area scans a specific class of product, do this, send them to this website. So the next thing we need is, well, we need a website. It needs to be a dynamic website to display variable attributes like when the product was harvested and so on, right? So we've got a dynamic website as well, and that's going to actually push the web content back to the browser and render it on the screen. But how did that dynamic website know what to render? Well, that means we also need a data repository. And our data repository follows GS1 standards to the letter, and we've got two parts. One is master data, so classes of product, locations, organizations, and certifications. They're all stored in there, and we follow the GS1 web vocabulary standard for that. On the other half, we need supply chain data. So everything we've been talking about so far, harvesting, shipping, receiving, packing, and all that kind of stuff, that's all stored as GS1 events in our GS1 EPCIS repository. So now that we've got the data in there, and the next question is, well, how did we get the data into there in the first place? Just like Kesel were talking about, you need various different ways to get data from legacy platforms that don't support the standards into a place in a nice structured standards compliant format. So the operational user interfaces we've got, smaller growers might want to just enter data manually using a user interface on a web portal, or they might want to upload spreadsheets, or they might want to scan individual, use mobile apps to scan and ship. Whereas larger growers, they always have existing systems. They've got picking systems, they've got manufacturing execution systems, they've got ERP systems, they've got warehouse systems. We need to do systems integration to get the data out of that, convert it into GS1 standards and store it in the repository. We've also got integration with sensor providers, a whole bunch of them, and we're getting those sensor data back and converting them into EPCIS format and storing them in context with the supply chain. The next question is, well, how did I get the codes onto my packs in the first place? Two things we need for that. One is a serialization engine that generates random serial IDs, so they can't sort of be guessed. So they're not really sequential numbers. They're fully randomized alphanumeric serialized identifiers. And we've got a print management component that takes those and can either print on demand in the production line, or they can send like a million identities at once and send them to a third-party label printing company, which can print out a label roll and ship them to the factory, then just apply and activate, right? The final pieces of the puzzle, I am running out of time, are the analytics and AI. So once we've got all this data, let's make it useful to the farmers and business representatives and so on. And we have, of course, the implementation of the GS1 EPCIS APIs to allow data to be shared to other businesses and organizations and regulatory bodies in the future in an electronic and friction-free manner. So these components are provided by TrackVision and the other consortium partners, but you can make your own, or you could work with any other providers. The important thing is everyone's following the standards. As the standards proliferate, we'll be able to reduce that integration cost to zero. And this kind of architecture you might recognize would be highly relevant to digital product passport, for example, for any of the industries that require serialized or batch level identities and so on. So these would be all the pieces you would need to be able to meet that kind of legislation as well. So unfortunately, a lot more I wish I could show you today, but we have run out of time. But if there's, contact me at any time at our website at trackvision.ai, or contact me on LinkedIn. We can chat about anything you'd like to learn